Hello my dear friends, today I'll explain to you how we can derive the Lorentz transformation equations. The Lorentz transformation equations between the two frames like K and K dash, which are inertial, and the Lorentz arrived at the equation to explain the Michelson-Morley experiment around 1887, which indicated that light appeared to travel at the same speed independent of the observer. Independent of the observer, like there's a source and there's an observer. Source is emitting the light wave. Observer, is observing it. Now, whether both are at rest, or the source moves towards observer, or whether observer moves towards the source, or both moves away from each other, whatever may be the relative motion. But the speed of light, it is independent of the relative motion. So the Dutch physicist Lorentz, by the way, shared the Nobel Prize in Physics in 1902 with the great scientist German for the discovery and the explanation of the German effect. Albert Einstein put forth the theory of special relativity in 1905. The postulates are, the first postulate is the law of physics are the same in all the inertial frame. Number two, the second postulate, speed of light in vacuum is the same in all the inertial frame. From the second postulate, we can derive the Lorentz transformation equations. Einstein also published in 1905 his famous paper on the photoelectric effect, which won him in 1921 the Nobel Prize in Physics. Now we will derive the Lorentz transformation equations in somewhat different way. So let's you accompany with me for the derivation, and I hope so you will enjoy also. Okay, so let we start. Thank you. Now we consider a light beam. Light beam, the light travels with a velocity 3 into 10 raised to the power 8 meter per second. It is emitted at the origin when the clocks are synchronized. The meaning of synchronized mean when the two frames were coinciding. Okay, when they were coinciding, like RT equals to T dash equals to 0. That is RT equals to T dash equals to 0. Now this is one frame, black one, red frame, the other one, K and K dash, and both were coinciding before. Now what happens? After some time, this frame is displaced from the black one. This black one is K, this is K dash. K dash is now displaced by some distance after some time, So it is displaced now. This is the new position after some time. Coordinates are X dash and Y dash. We call it K dash, and it is moving with velocity V. X, Y. So with respect to K dash, okay, K dash is moving with velocity V with respect to this frame. Okay. Now let the light is traveling in the positive X direction. That is at any time t, at any time t in the K frame, what is the velocity of light? And according to special theory of relativity, the velocity of light is a constant. So distance covered in any time t, in the K frame will be equals to distance equals to c into t. Likewise, and at any time t dash, now we are thinking that here in the K dash frame, the time is t dash, different from this time, which is t, because this frame, it is in motion, and velocity of this frame is, it approaches to the velocity of light. It is, not a very small. So it is comparable with the velocity of light. So that's why the two times are different. Here time is t, but here time is t dash. And at any time t dash, by this clock, with the clock which is in a K dash frame, by this clock, at any time t dash, distance covered is x dash. So x dash is equals to c into t dash, as this distance is measured in the frame by the observer in the frame K dash. Okay. Now, as we're taking the example, like the light is traveling along it is going along the positive x direction, but you may think light, we may take it along the negative x direction, no problem. Negative x direction is okay, because we are going to squaring this equation and this equation. So maybe it's a plus x or minus x, or maybe plus x dash or minus x dash, hardly any difference, because squaring the equation becomes the same. So light is traveling in plus minus x direction. So squaring both sides of the two equations becomes, x square equals to c square t square, and taking c square t square to this side, and this becomes equals to 0. And similarly for K dash frame, so this is equals to 0. Now just equation 3 and equation 4, right hand side equals to 0. If right hand side equals to 0, then left hand side will also be 0. So if right hand side equals to 0, that means x square minus c square t square is equals to, because this is equals to 0 as well as this is equals to 0. So that's why they are now equal. Now if this term is equals to this term, we are thinking like as the two are the inertial frame. Now we are having this term which remains invariant, which remains the same, whether it is a rest frame or it is a moving frame, no problem. That means this quantity is invariant. This is very, very important. We proved first of all this thing. Thus we are having a term which is invariant under transformations. Now what I'm doing, if I'm having a space, position and time space, like Minkowski space, like the position axis and the time axis with iota is imaginary. So this is an imaginary plane. And of course it is very difficult to draw something in the imaginary plane, but let's think about it. This is some distance in this plane, and how we find the magnitude of this distance. So magnitude of this distance becomes the root of OP square equals to OP square equals to x square plus iota ct whole square. Iota square is equals to -1. So OP square becomes x square minus c square t square. That means this term is basically some position in the position time space. Okay, we may think like this. And this, it is invariant. So we are having the example of the Minkowski space. So it is invariant. So this is like this is X and ICT one frame. Okay. Now we consider another frame. This frame is called K with axis, x-axis and ICT. And we are having another plane, another set of coordinates. Another set of coordinates. This is ICT, okay, in the K frame. Now we are having another set of coordinates like this is ICT dash and this is X dash. This is another frame K dash. Okay, shown with the red lines. So the two axes ICT dash, not IC, sorry, iota CT dash. Iota is the imaginary number. Okay, so this is X dash and iota C T dash. So this angle is, now we shown another frame K dash at some angle, which is that angle theta. So what we are doing, I'm having two frame K and K dash, which is made up of space and time coordinates. Time coordinates is imaginary, of course. But we just proved we are having a quantity x square minus c square t square, which is invariant. Under transformation. So whether we are having the black frame or the red frame, which is red frame is turned at some angle, but even then our basic term x square minus c square t square will be the same in the two frame. There is no dependence. Okay, so x square minus c square t square will not vary by turning one frame with respect to the second one. So now this is any distance. So perpendicular to x-axis is like this. And then perpendicular to x dash axis. Okay. These two are the perpendiculars, one on x, other on x dash. So now what we are doing, I am making the components of x along x dash, one component along x dash and other along to its perpendicular direction. So component along this side and one component along this side, the component of x along x dash, it is x cos theta, and this component becomes x sin theta. Now similarly, the components of ICT, this component and this component. One is this component, this component becomes IC T cos theta, and here becomes ICT sin theta. Okay. Now, what is x dash? Now, these two components, they will add up and becomes equals to x dash. So, x dash is x cos theta plus iota ct sin theta. So, this is the value of x dash in magnitude. Now, similarly, now we find one thing here, this component plus this one, okay, is equals to this. Or you can say iota ct cos theta, okay, or you can say, again, I can say ICT dash, this one, this is equals to, this component minus this component, because these two components are in opposite in direction. So ICT dash becomes minus x sin theta, because it is along negative direction, plus ICT cos theta. Okay, so this is value of the ICT dash. Now writing again this very important, I think you will understand, like this one equals to this value minus this value, okay. X and iota ct is the space. It is moving along the x iota ct, this is K frame, okay, and with velocity u. If we think that K dash frame is, fixed, and the frame K, okay, K dash is fixed, and frame K, which frame K? This one. So this frame is, moving along the positive x direction. K dash frame is fixed and K frame is moving. So what to do then? I am differentiating this equation with delta. Delta here, so delta with each term. Delta means change or differentiation. So delta x dash is 0. Why? Because K dash frame is fixed and frame K is, moving along this side, along this direction. So delta x dash is equals to 0. Okay. And from here we find delta x over delta t. So what is delta x over delta t? This is the velocity v. Velocity v becomes equals to iota c tangent theta. or tan theta becomes equals to minus V upon iota c, or minus mean iota square. Iota and 1 iota cancels. So tan theta becomes iota V upon c. Now we consider a triangle. We consider a triangle. Like this is here, theta. Now tan theta is perpendicular over base. Iota V upon c, base is 1. And hypotenuse becomes base square plus perpendicular square. And iota square is equals to minus 1. So this is 1 minus b square upon c square. From this triangle now we can find sin theta and cos theta. Okay. Now sin theta becomes perpendicular over hypotenuse and cos theta becomes base over hypotenuse. Now substituting the value of sin theta and cos theta in this equation, in the above equations. Okay, substituting the values of sin theta and cos theta in the above equations. So first equation becomes, just solving, substituting cos theta, because cos theta is equals to this and sin theta equals to this value. Substituting here, okay, and iota square mean minus 1. So the equation becomes x minus vt upon root of 1 minus v square. This is the first Lorentz equation for x coordinates. Very, very important. Okay. Now substituting in the second equation. The second equation becomes it's just substitution and simplifying. And simplifying. Now iota cancels and c is also simplified because it is in each term. So we are getting the equation for t dash. T dash becomes equals to T dash becomes equals to T upon this parameter. So 1 upon root of 1 minus v square over c square, sometimes it is also called gamma. So T dash becomes T, the denominator is 1 minus v square over c square, and the numerator T minus xv upon c square. They are the two equations. And because y and z axis, there is no problem for y and z because the frame was moving only along the x direction. So there is a change in the x and time, but there is no change. There will no change in the y and z coordinates. So y dash will be equals to y and z dash will be equals to z. Y dash equals to y, z dash equals to z. So this is a relation, this is the relative motion of the two frames with respect to the x-axis. So that's why change in x. Change in this x equation with velocity v. So we are observing, we are observing sitting in the k dash frame. We are observing sitting in k dash frame to frame k, and with that the frame k is moving with velocity minus v. So that's why here. And now there is a reverse Lorentz transformation equations. They're very simple to how to get the reverse Lorentz transformation equation, prime to unprime and changing v to minus v, v to minus v and prime to unprime. Okay, then we'll get the other set of equations called inverse Lorentz transformation equations. So x equals to x dash plus vt and 1 minus v square over c square. So this is another set of equations. Now to prove that, now next is Galilean transformation is the special case of Lorentz transformation. Very simple. To verify it, we consider v is less than c. When v is very small as compared to c, then v over c can be neglected. V square over c square can be neglected in the denominator with respect to 1. So v square over c square is neglected as with respect to 1. Okay, with respect to 1. So the equations turns to Galilean transformations equations. Very simple. Thank you very much. Please subscribe my channel. This is a derivation of the Lorentz transformation equations. Okay, thank you.